Hold up.
Hi, I'm RG Flores, and my topic today is thermoelectric generators, also known as TEG. So, what is a TEG? Basically, it's a device that converts heat into electrical energy. We also know that there are three types of thermoelectric operating modes. The first being cooling, the second being heating, and the third being power generation. In power generation mode, as heat travels through the TEG, power is created. And as the temperature difference between the TEG increases, the output power also increases. So in our TEG, thermoelectric generator, we have these two output wires. We have the red, known as our positive. Then we got the black, known as our negative. So here we have is the thermoelectric generator, specifically a SP184827145SATEG. So basically, it is made of two ceramic substrate, one side being the hot side where heat is applied, and the other side being the cold side where heat is dissipated. And in between these two sides sandwich is a N-type and P-type semiconductor pellets. By exploring a temperature gradient, or what we know as a temperature difference, between the two sides of the generator, heating one side and simultaneously cooling another, the heat flows through the semiconductor, thus creating a voltage, which we know as the thermoelectric effect. To start off this demonstration, I wanted to introduce one other material needed, and this is called a heatsink. A heatsink is a device or substance used for absorbing excessive or unwanted heat. Next material, we have a silicon compound. A silicon compound is used to keep heat isolated within the thermoelectric generator itself. So for my base of my demonstration, I use a jar. And in order to complete this base, I would like to put this chopstick in. Then as for the source of thermal and heat energy, this candle will be placed inside the jar and be lit. So just stack them up inside. Here we go. Then we have a metal plate. So this metal plate will be placed on top of the lit fire and the chopsticks and be served as the source of heat, and where the TEG will then soon be placed on. So for the next part of this demonstration, we take the silicone compound, take a dab of it, just a small dab, and we make sure we apply it not to the hot side, but to the cool side of the TEG. And slowly spread it on the whole side. So again, the silicone compound will make sure that the heat is just isolated to this cool side of the TEG. After slowly spreading, we take the heatsink, make sure it's the bottom surface, and we place it onto the top of the cool side. Slowly, and just like that. So for our next step of our demonstration, we take these alligator clips and we connect them to the output of the TEG. Here we go. Got the black to black wire. That's connected. And we got the black, red to red connected. So here we have is an LED light. So this will serve as our output voltage and a sign that there is voltage flowing through. Connected to the positive. And connect the black wire. Now we have a lighter. So this lighter will light this candle up and serve as a heat source. Go, just light it. Oops. There we go. Now that our light is on, we place a metal plate on top. So now that's on top, we shall place the heat side of the TEG onto the metal plate. So if it's not working, the polarity must be reversed, so let's go switch it. So like most electrical generations, which is the result of a movement of a magnetic field across a conductor, in this case it's the movement of heat from the heat source through the metal plate and through the TEG and the semiconductors, which causes electrons to flow, thus creating an output voltage, which can be seen in this LED. So here we have is a DMM. So this DMM will be used to measure the output voltage over TEG. So we take alligator clips connected to the TEG and we connect them to the pros of the DMM. There we go. That's one. And we got the second. So this time I'm going to replace another candle and light this candle up to be as our heat source. Let's turn this on. Alright, we got the fire started, and now we place the metal plate again, and we place the heat side of the TEG onto the metal plate. Now we'll turn on the DMM to the voltage, and now we can watch the voltage rise. Should be rising. So of course it'll take a while for it to heat up. So as the temperature increases, the temperature gradient increases, the voltage increases. So the next step is we take these alligator clips and we connect them to the output of the TEG. There we go. Black to black. And red to red. Now to make our source. We take this lighter and we light up the candle. Here we go. There we go. We got the fire starting. Place our metal plate on top. Now here we have the TEG. Make sure the heat side is on right directly on top of the metal plate. So then we have a DMM. Connect the DMM. Turn on the voltage. There we go. Just connect it. Then, there we go. As we can see, we have an output voltage. Kind of close in. And as of right now, the voltage is increasing 2.5, 2.56. So here we have the heat from the candle transferring to the metal plate to the hot side of the TEG, and this heat flows through the semiconductor, thus creating an output voltage. So in conclusion, a TEG, a thermoelectric generator, also known as a CVEC generator, is a solid state device that converts heat through a temperature difference into electrical energy through a phenomenon called the CVEC effect, also a form of the thermoelectric effect.
Hold up.
Oh. Thank you again, guys. I'm RG Flores, and I'm out.